Friends, today I am going to teach you about area of plane figures. Some of you know the formula to calculate the area of some figures, but in this chapter we are going to consider some complicated shapes, plane figures. In the past classes, you learned how to find the area of simply a square. This is a square. Square, you call it, you represent this. This is a side, yes. Similarly, this is, again, this is also side here, side, yes. So, the area of a square, the area you are calling it as you know, that it is equal to s square, and it is square units. It is square unit. This one is a square units. That means if s is measured, if f is measured in centimeters, then area will be in square centimeters. If f is measured in millimeters, then the area will be in square millimeters. Similarly, meters, square meters, like that. Now, the next one you know, I want to quickly brush through the various shapes. This is a rectangle. This is a rectangle. In the case of a rectangle, you know that if this is the length of the rectangle L, and this is the breadth of the rectangle B, then the area is equal to L into B. And then you also know, in the case of a triangle, if this is the altitude, let us say the triangle is ABC and AD is the altitude. That means the perpendicular drawn from A onto the base BC, that is AD. That we call it as the height of the triangle. This is called height, H-G-I-G-H-T, height of the triangle. Height of the triangle. So that means if you take BC as the base, then AD is the height, altitude. You can also call it as altitude. Now suppose you draw a perpendicular from C to AB. That means this angle is 90 degrees. Here in the case, when you drew a perpendicular from A to BC, this angle is 90 degrees. Similarly, let us say this E. So CE is the altitude for the base AB. So always base and altitude go together. You cannot take one particular base and then multiply by another base. So if you take base BC, so if you take a triangle ABC, already you have taken the base as BC, that means B and C are gone. So you are left with only A. From A on to BC the perpendicular. Similarly, suppose in the same triangle, let us say I will take AB as the base. That means what is left? C is left. That means from C on to AB, I draw the perpendicular. So, in this case, the area of the triangle, the area of the triangle, we call it as like that. That is how we write it. Area of triangle ABC is equal to half into base into altitude or height. Let us say height. I will call it as height. You can also call it as altitude, there is no problem. So these are the three fundamental ones. Now from these two, we go to a parallelogram, a trapezium, a rhombus, a kite. Kite, I'm sure you all know. On Ugadi day, what do? You fly a kite. So a kite is something like this. That is a kite. You know what is a rhombus is? Rhombus is like a diamond. If you see the deck of cards, playing cards, you see a diamond red. It will be in the color red. All the sides are equal. So anyway, these are the three fundamental shapes. From these, we can derive the areas for other plane figures. These are all called plane figures because they are contained in one plane. Contained in one plane. So now, now we learned about the area of a square, area of a rectangle, area of a triangle. I want to tell you something here, very, very important. In practical geometry, if you understand the triangle, the properties of the triangle, like a perimeter, area, like that, if you know the triangle very well, I would say about 75% of plane geometry you already know how to find the areas of different figures. The only thing that is left in your syllabus is a circle, a combination of different circles and all that. But important thing is area of the triangle. You have to understand the triangle very well. I will tell you, suppose if I draw a triangle like this. This is A, let's say I will use some other term, P, Q, some other letters, P, Q, R. Now if I take QR as the base, then I have to draw a perpendicular onto QR from P. Suppose if I take PQ as base, then I have to draw a perpendicular like that. Suppose if I take PR as the base, then I have to draw a perpendicular like that. So if you take PQR as the base, then this should be the altitude. And if you take PQ as the base, then this will be the altitude or height. Similarly, when you take PR, this will be the height. So you basically the rule is like this. A triangle can be represented by three letters. It can be XYZ, or LMP. No matter what, tell me any name, tell me any notation. Let us say I will say XZP is a triangle. So if you take XZP triangle, now if you take HZ as the base, that means you have to draw the perpendicular from P onto HZ. And the area is equal to half into XZ into HZ into from the perpendicular from P onto XZ, let's say PM. That's how you calculate the area. So that means when you want to find the area of a triangle, fix a base. Whichever is easy one for you, fix a base. And then when you take the two letters out, you are left with only one letter. Draw a perpendicular from that point onto the base. That is your height or the altitude. This half base into height is the area of the triangle. So now, after you learned about the three fundamental basic shapes, then you have what is called the parallelogram. This is a parallelogram. Parallelogram means these two lines are parallel. These two lines are, I will say, these two lines are parallel. In addition, these two lines are equal. These two lines are equal. That means in a parallelogram, opposite sides are parallel and also opposite sides are equal. Suppose you want to find the area of a triangle, area of a parallelogram, then again, let me see, PMN, say S, PMNS. Now if you take the PM as the base, the area of the parallelogram is equal to, you extend it and drop a perpendicular, then the area of the parallelogram is PM into, let us say this is R. So NR is the height. We call it as NR is the height. PM into NR, that is the area of the parallelogram. So that means here NR is the distance between the two parallel lines. Suppose you take SP and NM, that means you extend it and you drop a perpendicular here. So the area of the parallelogram is SP into N and Q. SP into N, Q. That's how you find the area of a parallelogram. Now you have a rhombus. For the rhombus, all these you have, I think you already learned about these areas of these figures. Rhombus. So rhombus has all the four sides equal, opposite sides are parallel, and the diagonals bisect each other, and they bisect at right angles. These are the properties of a okay. Well, these are the properties of a rhombus. Now, if D1 is at one diagonal and D2 is another diagonal, the area of the rhombus is equal to half of D1 into D2, where D1 is one diagonal and D2 is the other diagonal. Lastly, we have a trapezium. We have one trapezium that I did not, I want to touch base with you. There is a trapezium, trapezium is one where two sides are parallel. That means the distance between these two is always constant. This distance is constant. Again, you have to find the area of the trapezium. So anyway, now if I summarize it, in this class, all I did is I touched base with all the information you know so far already. You already know. Now we will apply this. In the next part, we will apply this all the rules you know, all the formulae you know. We will apply that to find the area of a complicated shape. Let us say there is a shape like this. Suppose you have a shape like that. I want to find the area of this shape. How do you find the area? How do you find the area of this plane figure? It's very easy. Now, by looking at the figure, don't get baffled. Oh my God, this one I never. My teacher never taught you. My teacher never taught me how to find the area of this complicated figure. It's very easy. It is very, very, very easy. And all you have to do is, you know the area of a rectangle, you know the area of a triangle, you know the area of a square. So you basically what you do is convert this figure into the shapes that you already know. What you already know, you know a triangle, you know a square and a rectangle. These are the three fundamental shapes. Once you know this, then you can find it. Suppose if I draw a line like this, then what is this? This one, number one, is becoming a, what is it becoming? A rectangle. Now if I draw a line like this, number two, this is a trapezium. This line, these two lines are parallel, this is the height. And now I draw a line like this, then what is this? This is a rectangle. Now what is this one? This is 3, this is 4, this is a triangle. Now what I will do is, here I will draw a line, this is a triangle. Now if I draw a line like this, then this becomes a triangle. And if I draw a line like that, and then if I draw a line like this, now it's a triangle, triangle, rectangle, triangle, like that. You can see now how easily I divided the complicated shape into small, simpler shapes. So once you know, once you divide the complicated shape figure into the various sections of known figures, you know for a square what is the area, you know what is the area for a triangle, you know what is the area for a rectangle. So knowing these, if you convert that, then it is the algebraic sum. It is a sum, not algebraic. It is the sum of all these individual areas. When you put together, you will get the total area. So once again, in this part, what did I teach you? I touched base with all the fundamental shapes, plane figures, and I identified the formulae for the fundamental figures. I also told you triangle is very, very, very important, because you know, even if you forget formula for a rectangle or a square, if you join, you can easily convert a rectangle. If I draw a line, that means you are dividing the rectangle into two triangles. So you know the triangle formula, you can easily calculate the area. So area of this plus the area of this is equal to the total area. Similarly, square. Now if you draw a line like this, you are splitting the square into two triangles. So that's why I tell you triangle is very, very important. Once you know whatever may be the type of triangle, it can be a scalene triangle, it can be a right angle triangle. Oh, right angle triangle, you are lucky. So you know the altitude already right away. Or equilateral triangle, isosceles triangle, any triangle, you should be able to figure out the area very easily. Mind you, area is always in square units. So it is either square millimeters, or square centimeters, or square meters, or square kilometers. If you talk a vague area, it can be kilometers. So once again, I hope you understood what I taught so far. Tomorrow, in the next class, we will take some complicated shapes and split them into known figures. Known figures are, what do you know? What are the known figures? Rectangle, triangle, and a square. You convert them, and sometimes you can even convert them into a parallelogram too, so or a rhombus too. But anyway, these are the three fundamental shapes that if you know the formula, if you know how to calculate the area, then you're all set. It's a piece of cake. It doesn't cause you any problem. You will love it. This chapter in mathematics, anything related to geometry is always fascinating because you can see the result, you can see the diagram and all that. Suppose if you have an algebraic equation, that's a slightly different story. But here, practical geometry, plane geometry is very, very interesting. You already seen how to bisect an angle, how to construct an angle, how to construct a triangle, how to construct a quadrilateral, like that, different shapes. You already know. You are in the 8th class, I'm sure you know all those. So here in this case, we are going to use the basic formula. Using the basic formula of the fundamental figures, shapes, we will find the area of the complicated figures. Well, thank you. Thanks for listening to me. I hope it is clear to you. Okay, thank you.